Hello everyone and welcome to the CSE116 Task 2 overview video. In this video we will be going over linked lists and inheritance a little bit, and we're just going to be going through the task and talking about some things here and there, just like the other ones. This one should be a little shorter though. Yeah, so you guys know about linked lists by now. That was already in the problem set. You guys are professionals at that at this point, but just in case, we need a little bit of a refresher on that. I pulled this image here right from the slides, but I replaced the integer values in it with a generic data box, and I provided Google defines a linked list as a data structure that stores data in a chain of nodes where each node points to the next. Wonderful, concrete description there. But yeah, so basically in memory, this is what a linked list is going to look like. Again, you guys are probably at least a little bit familiar with this by now. It's just basically boxes of data that hold boxes in memory that hold some type of data and a pointer to the next linked list node. And that's basically all it is. It's like a one-way chain going all the way until some node points to null. But yeah, so those are linked lists. We're going to be talking about the physics engine with gravity part of the task, and how it's so much simpler to make because of inheritance. If we didn't have inheritance, it would be a lot trickier. We'd have to write code that does the exact same thing as our old physics engine update object method. So we'll talk about how that's going to be much more optimized now that we're able to use inheritance. And switch case. Some of you might have never heard about what a switch case is, but it's going to be worth mentioning because we're going to have to modify some code in this task that uses a switch case. And we're just going to compare it to some things that you guys already know. It'll be hopefully it'll click. It's not too difficult of a concept at all, but we definitely got to talk about it. And yeah, for your testing utility, it's going to be a static method here. We'll go over that again when we look at the doc. But when we go over the testing utility, we're going to talk about some other ways to traverse a linked list and yeah, stuff that's going to be really useful in the future. And yeah, I don't know. I'll talk about that later. But anyways, let's go look at the doc. All right, so looking at the doc here, we have our overview section of the learning objective part of the game features after the problem set. You guys know the drill by now. So again, like I say in all the videos, you guys should read this before watching this, of course. But if we go through this here, we see some necessary information that we need to complete this task. First of all, before I go over anything, I'm going to show you guys what the completed game should look like for the learning objective portion. And I'm going to show you right off the bat what it's going to look like for the CU, because for this task, I strongly recommend that you do the CU. It is very recommended that you complete the CU for this task because it'll help you so much more in task 4. So I definitely really consider it. But anyways, so right now I'm in the configuration file, which you could always find by pressing shift and then typing configuration. I'm going to change the game name here to Mario, and then I'm just going to run the start game. And we're going to see Mario. I turned off the audio because it was super loud. Oh, well, I still got that one. Okay, so I'll try to talk over this. But so, yep, this is what it's going to look like. It's Mario, and you could play the game for the most part. And you could just jump around, and you see the gravity working and everything. It's pretty cool to just, play it and know that, like, you help make the mechanics for this. So, it's really cool. But yeah, also a big thing here is not only the gravity that works, it's also the level management. So once you complete your level stuff, you'll be able to go to the next level, and you'll be able to see all that working. It's super loud, I'm sorry. I'm just going to get to the end here to show you one more time. You just hit the pole, you're going to go to the next level, and yeah, it works great. And as long as you have all of your methods implemented correctly with advanced level, storing all your level data and all that, then it should work, and you'll be able to play Mario, and it's super cool. Yeah, so that's Mario, and that's going to be the learning objective portion of this task. But I'm also going to show you the CU, what that's going to look like. To do that, I'm going to change this thing in here really quick. I'm not showing anything critical because this is actually all given to you. If I'm gonna go over this in a little bit, but this agent class, um, we give you a bit of code that you could just copy right in or write yourself. Which, you know, this is described to write yourself. Again, I'll go over this in a little bit, but this is to help visualize what your CU code is doing for this task, because you're not going to be able to like play anything directly yet, because that's going to be done in task 3. But now if I go to sample game and I play this, we're going to see, hopefully, yeah, okay, we're going to see some pathfinding stuff. So we see the paths generated by these two demon entities. One was up there, it started like in the top right, and it pathfinded right towards me. It's fine that they're going through the walls. That's like how it's meant to be right now. But as you can see, this guy started down there, and as he went closer, his path changed and got shorter. I'll show that one more time. But it's really cool to see the visual here, and that your pathfinding is actually like working. Because later on we're going to make it way smarter with them going around walls and stuff like that. But for now, it's going to help you so much for task 4. So keep that in mind. I really strongly recommend that you guys do the CU for this task, and it's also pretty cool to watch this happen. And again, like I mentioned a bit earlier, there's some tactics that you might be able to use to make this be a lot easier than it might be with a iterative, you know, while loop method. But you know, we'll get into that in a bit. So let's take a look more at the doc. So yeah, like always, we see that there's only a few files we need to modify, which are these 4: linear game, physics engine with gravity, level parser, test utils. So again, if you're overwhelmed with the bulk of the project here, there's so much stuff in here, you could just shift it and find whatever you want. So if I wanted to find linear game, you know, I know, like I've mentioned this before, but I always mention it because like I know it's an overwhelming, like there's a lot of files here. I understand if it's like hard to go through all these, and like a lot of them you don't need to ever look at. Like this display thing, you never need to go in here really. Like there's many files that you'll never have to look at, but this is kind of the point of 116. Like if you want to look at it, you can, and you'll probably be able to understand a lot more as you learn more in the class. So it's really cool stuff. We built, like, this engine was built around like the concepts that we learn in class and everything. So it's really awesome. Now there's a few notes right off the bat in the overview that we should definitely do here, which are, first of all, to download this test2 class into your app.test package. So if we click on this link, it'll just give us this, and we should download this right into our testing package, which is just right click, save as, and you'll save it to your downloads, and then you'll be able to just drag it right in to your tests here. Which, if you need to figure out how to go to your like directory, normally you could just right click on this, and there's an open in button, and click on Explorer, or it might look a little different for you, but generally that's what it's going to look like. And then yeah, you want to paste that download into here, so I'll do that really quick. Yep, okay, so I downloaded it and it's in my downloads, and I'll just drag it right into here, and now I'll see it in my game engine. So great, perfect. And these tests will help us automatically test a whole bunch of stuff for our task. And like as we see, there's some errors because we haven't implemented these methods yet. So yeah, we have to download that, and then we also have to download these testing files in the same exact way. So I'm not going to show that, but this time they go in data/levels/testing. So just download these 3 and paste them in to it's up here all the way at the top, so it might be a little confusing, but data/levels testing, and just put them in here. I noticed that there's already a medium.tsv here, and it gives us this, so it's fine to override it if you want. You could also just compare the two if you want, but I overrid it and it worked out just fine. So yeah, anyways, so that's all the prereqs that you should do before even looking at any implementation stuff. So let's move on to some other parts of the doc. So yeah, a lot of the first portion of this task is very similar to your problem set. Um, I would really take a look and compare the two before you start just blindly writing code, because there's a good chance you might be able to salvage some stuff from the problem set, and think about how you might use that to implement it for this this part of the game features task. The linked list stuff, again, like I'm not gonna go over too many things of these methods here, like getters and setters. You guys have done those at this point. The interesting ones are remove level by name, advanced level. These two are like the most interesting linked list methods here. But again, if we just look at the problem set, you guys did stuff such as delete element. You have an add element here. So just take a look at what you did already and compare it to here. And advanced level, that's going to be probably the most unique one. I think it's pretty descriptive, and yeah, nothing too much to talk about there. One thing I do want to mention though about advanced level and kind of these linked list methods in general are to be very careful about modifying your instance variable for your level list, because this is an issue that runs up all the time. Like, if you're advancing your level, you're still gonna need your entire level list. Okay, like, you shouldn't change your underlying data structure when you're calling advanced level. So keep that in mind. Like, if we added like 10 levels to our level list and then we call advanced level, we should still have 10 levels in our level list at the end of that call to advanced level. Just make sure you're considering that and that's on your mind. And yeah. So where things get pretty interesting though is with the physics engine with the gravity part. Here is where we look at inheritance and really see a huge benefit of it. So we're tasked with looking at the physics engine with gravity class, which extends physics engine. So physics engine with gravity is a subclass of physics engine, which if we take a look here, because it's really useful if we just go in and look at this stuff. Physics engine here, I just shift and got there. So we have a whole bunch of methods in physics engine, but again, we don't really need to do anything in here. So that in a previous task, you guys would have completed this update object method. Excuse me. And there should be stuff in here for you, but that's where we really see a benefit, because if we go to physics engine with gravity, we're tasked with overriding the update object method of physics engine. And in this override, we still call the superclass's update object method, which basically this means that like your subclass is still calling code from your superclass and executing that first and then doing its own logic on top of it, or vice versa. So we actually are going to set some gravity to the velocity of the game object, and then we're just going to call our superclass's update object method. So we don't have to rewrite our like velocity shifting like movement method, because we could just simply extend it and add some extra behavior to it. That's the real power of inheritance. So remember, like how you override something. You basically just repeat the definition of the method in the subclass, but you should really write the override method to make things super clear. And that's another great thing about like kind of working in this big file space, is that like you can see a bunch of examples of the stuff that we're learning about. Like right here, we could see that process all collisions. Apparently this is an overridden method, which means that our superclass physics engine probably has a method, well definitely has a method, process all collisions, unless it was in some farther superclass like down the chain a bit, but it's not. This is like the most low level class here. So yeah, process all collisions. So we see a lot of interesting behavior here, and yeah, like I said, we're gonna be overriding the update object method and adding some gravity to it. And it's pretty simple in terms of the amount of code that you have to write. It's not too much, and that's the goal of our inheritance. We don't want to rewrite all of our code. again. So yeah, definitely keep that in mind. We have a get gravity and set gravity method, so just getters and setters again. We're gonna want to create an instance variable for gravity and store that ourselves. So we're gonna be storing that somewhere in here, somewhere at the top, and yeah. So we'll be able to see how gravity works now with all that. And technically, Mario and all that, after you complete this physics engine stuff, is going to make Mario work completely. You'll be able to jump up and down and all that. Okay, moving on. Again, this reset method here, it's completely optional. It'll just help you debug like quicker if you'd like. So remember, you don't have to do this reset method, but keep that in mind there. Yeah, and so we're gonna move on from the gravity stuff and go right into the level parsing. Now this is interesting because here's where switch case comes in, and we don't expect you to have seen switch case really at this point. So I'm going to show you what it is, how to use it, and how it is basically exactly like if else's. So let's get into that here. Okay, so I have an example method here just so I could write some code and we could look at it. So what a switch case is basically just a long if else statement that's easier to read. And that's pretty much it. So I'm going to write one out before we take a look exactly at what the level parser is doing, because I think it'll be easier to understand. So just really simply, a switch case, you write switch and you give it some data that we could examine different cases of what it could be. What I mean by that is, like, let's say we gave it an integer, some integer variable, right? Then we could look at different cases of what that integer could be. So I'll do an example here. So let's just say, let's say this method passes us in an integer called x, okay? And we want to switch x. So then we open up the switch case, and then we start adding cases. So let's say, all right, for int x, the case that x is 0. And then we put a colon, and then we write out our code. Like, okay, if x is 0, then maybe, let's say we were returning a Boolean or something. Like, who knows what it is, right? Then, okay, let's return true. Great. Now let's say the case was 1. And so, yeah, you'll notice that with switch cases, like, for some reason in IntelliJ, like, when you press enter here, it'll start you on this line, and no matter what, you can't go back one. So you have to just go type it here, and then it'll automatically adjust once you type the colon. But case 1, let's return false. Okay. And that's like a super basic example of a switch case. Now I want to bring up a few more things about switch case. So I'm going to make this void again, and let's pass in a string this time. So, and let's just call the string name, okay? And now let's switch on name. So if we're switching on name, we could go cases with whatever names we want to put in here. So I don't know, I'll put in Jesse. So in the case of Jesse, who knows, we could do something. I'm going to also mention one part about the switch case syntax, which you're not going to have to use for this. I'll explain exactly what you're going to need to use when we look at the level parser itself. But let's say we want to do something like, I don't know, let's say we have an int like sum, and we started at 0. And if the name is Jesse, for some reason we want to add 5 to sum. And once we're done, we want to write break. And break is basically saying, like, okay, we're done with the switch case, let's get out of the switch case. But let's say it wasn't Jesse, then we still have other cases to go through. So maybe it was Paul, and if it was Paul, let's add 3 to the sum, and then we want to break again. So break is useful when we don't want to return like the method, but we still want to do stuff afterwards, but we do want some output from the switch case. So super basic examples of a switch case here. If we were returning an int, we don't need the break if we're just returning. So let me switch this method signature a bit, make it an int. Let's say if we get Jesse, we just want to return 5. And if we get Paul, let's return 3. So, and the only reason this method's giving an error is because we don't have like a default value after the switch case. But that's in a nutshell like the most basic use cases of switch case. It's the same exact thing as if else. It's just built a little differently for visualization. You might be asking, why not just use if else? The reality is that you could. The only reason we use it is because it's easier to read. So I'm going to write the same exact syntax in an if else sense, and you'll see what I mean. Okay, so wrote out that if else if statement, and these behave the exact same. The only reason why I'm getting an arrow is or a yellow line is because the switch case is already returning. But this is just for the example. If I commented this out, it would work the exact same as the switch case did. So, the switch case just looks a little bit more readable. Our cases are pretty direct, like, okay, Jesse, return 5. Here it's like a little more like messy, but they really do the same thing. So when you see a switch case, don't feel intimidated. And so now we're going to look at the level parser. And this method is just garbage, by the way. I just did it for an example. But let's look at read dynamic object, for example, in the level parser. So I'm going to go back here, press Shift, and just type read dynamic object. Yes, Shift works with methods as well. So we're right here in the level parser, and we see a switch case. So this switch case is switching on split.get of 1. What the heck is that? Well, we see that split is an array list of strings. So an array list dot get of 1, so that's some string. We're switching on some string. Okay, that makes sense. So that's just the same exact thing as our name example from before, right? Like, we're switching on some name. Okay, it's basically doing the same thing. So if the name is daemon, then we're returning a new daemon object. Right, because a daemon is a dynamic game object through inheritance, so that makes sense that we could return it. Because if we click on daemon, we see that it extends enemy, enemy extends agent, agent extends dynamic game object. So it's this whole big tree of things, and we're slowly going backwards and backwards. So a daemon is a dynamic game object, so we could return it as one. So great. And we're doing that for tower as well. And don't worry about this default thing. Default is basically just the else of a switch case. So if we wrote here, I'll go back to our test utils. If we wrote default here, it's like, okay, if it wasn't Jesse or Paul, let's just return 1, and that would take care of everything. So that's just what default is. It's basically just the else part of an else if statement. So let's go back to the read dynamic object method. And yeah, daemon tower, and we see we're tasked with adding Goomba and Koopa. So it's really not too different than anything we see already. We're just trying to get you used to, like, okay, when we're adding more things to a big project, we have to change our parser, and this is how we're going to actually be able to see our new, Goombas and Koopas in our Mario game. So think about how you do that, and then it's basically the same exact thing for the read static object, but I want to mention one more thing about a switch case. All right, so I'm going to get rid of this if else if thing because that was just for the example. So one more thing about a switch case is that you could take care of multiple conditions at once pretty quickly. And I'll show an example of this here. So I'm going to add another case, but I'm going to say, and just for the heck of it, I'm just going to do it between Jesse and Paul. No reason. But all right, I'm going to add another case, okay? And I'm going to say, what if it's Bob? I don't know who Bob is, but if it's Bob, then I want to return 1. Okay, simple enough. We have Jesse, Bob, Paul. This is completely optional. You could get the picture done the same exact way by just adding, like, let's say we have 3 people, Bob, Alice, and I don't know, I'm just making up names here. So, like, let's say we had, like, Bob and then, like, Alice. They're both returning 1. Like, they're, like, doing the same exact thing, right? But we're using 2 cases on them. We can make this a little easier to read by just adding a comma. So, Bob, comma, Alice. Simple as that. And I'll get rid of this one here. This is doing the same exact thing. If it's Bob or Alice, we're returning 1. So that's a way to do it. And I'm not going to go too much farther on that. But if that helps you out at all for your read static object, then that's great. Don't have to use that. But just something to think about there. So I can't say too much about the parse level method modification here because, well, all that code is stuff that you guys wrote for task 0. But what I will do is I want to show the example of what the level CSV files look like and where that type actually is in terms of if it's a top-down level or a Mario level. So if we take a look here inside the project, this is an example of a Mario level. So we got so much static game object data in here, right? But we'll notice that the very first line and the very first entry is the level type, Mario level. If we take a look at some of these other levels here, we got top-down levels. It's always the very first entry, very first line, very first value. It will always be the level. So keep that in mind when you're creating your parse level modification. Yeah, because you have to make it dynamic to the level type. So if it's a top-down level, you should create a top-down level object. If it's a Mario level, it should be a Mario level object. Right now, you probably have them all being top-down levels, so take a look at your code, see how you could change it to check this first value, and depending on what this first value is, make the corresponding level. So good luck with that. But that's pretty much the hardest part about this part, about the level parser class. It's really just like understanding what you need to write, and knowing what the switch case is. So that should go relatively smoothly, at least this part of the task. Now the testing utility. Now this is an interesting one because you have to write a static method and compare two lists of levels. Now, for an exercise, it would be really great if instead of going through these linked lists in a while loop fashion to compare them both, I would encourage you to attempt this problem with recursion. And the reason for that is because if you get recursion down now and just get some practice with it, you're going to make your future tasks much, much easier. And recursion is just a great thing to practice. So I would very much recommend that you try to compare two lists of levels in a recursive manner. I'm not saying it's required or anything. It's like you could do it however way you want as long as you get it done. But I'm going to recommend try this out with recursion. Try many things with linked lists out with recursion. Wherever you think you can, that like where it kind of makes sense, try it. It's a good practice. So keep in mind that you're taking in two lists of levels, linked lists, and we're comparing them to make sure they're exactly equal. They have to be the same length and have the same names. So think about like when you're thinking about recursion, you have to try to boil it down to like your simplest steps. Like what about these two lists do we have to check in like the smallest step? So and to answer that for this one, that would be comparing a certain level of each of the two at the same time. We're comparing two names of two levels, and we're trying to assert that their names are equal. And we have to do that for every level in each of those two lists, and they should be the same length. All those names should match up. So yeah, the testing utility is definitely a really great exercise for recursion. I would recommend it. And to emphasize some things about the testing requirements here, you don't need to test anything about the gravity or the level parser. That is all done for you in what we pasted in earlier test task too. So once you write your code for that, the physics stuff, you could just run this file here and see if you pass. I'm not even going to be able to run it because I'm getting an error because I don't have these methods written yet. So yeah, definitely run this when you can. After you add your methods, it'll tell you if you're doing it right. So yeah, that's very important to do. Only thing you need to test is your linear game level stuff. So add level, advanced level, remove level by name. Something that people are having a lot of questions about, and a lot of the times when you're having trouble writing tests, you should look at your given tests for examples on how to write good tests. I know that might like seem obvious to some people, but if it's not to you, Like, these are good examples of how to write tests. Like, if you don't understand what's going on here, take a minute and just read some of your given tests. Like, assert equals. Like, why is this going to be helpful for testing this game? Um, Make sure you know what these assertments do. Like, assert equals is like, okay, I will fail the JUnit tests. Like, I will fail the tests if these things are not equal. That's what writing an assertment is doing. And there's a whole bunch of assertments. There's assert equals, assert true, assert null. So keep those in mind when testing your linear game. And definitely try to use your testing utility for the add level method. So that's the whole reason we have you write it, to make this testing this method easier. And the way you would do that is by adding a whole bunch of levels to the linear game. So I'm just going to write an example. This is not going to actually do anything, but I would name this something very descriptive, like test add level specifically. I don't want to write all my tests in one method, and label it with the at test annotation. And then I would make an expected linked list of levels. Because remember, our testing utility takes in 2 linked list nodes of levels. So that's 2 level lists, right? One of those are going to be one that is man-made by us. And the other one is going to be one that we add levels using the add level method of some game, and then call get level list later. And we're going to make sure that get level list is the accurate list of levels. That's how we'll know that add level actually was doing what it was supposed to. So it's definitely an important thing to learn how to make like some linked lists. And I'll show you one way how to make a linked list like pretty cleanly. So if I want to make a linked list node of levels, I could do it like this. You know the basic syntax. We'll give it some name, and we'll call it like expected list. This is what we expect our level list to look like after we've added like some levels. Okay. So we'll make this equal to a new linked list node, and a linked list node takes in a value and a next. So like we said for the values here, we want to be adding in top-down levels. Okay, so we would make a new top-down level, and top-down level takes a game. So again, we have to make sure we have a game. This is all explained in the doc. So linear game, I'll just make that really quick, and we'll pass that in. And then we could pass in whatever other parameters here. And a name, I don't know, we should give this a pretty descriptive name so we could compare it later with the debugger or whatever we want. So I'll call this one Bob. And then here's where it might get a little different to your guys' view of like creating new objects. And you don't have to do it this way. This is just a way to make it a little cleaner. Then we can make another linked list node and do this whole process again. So this is the value of next for this linked list node here. This is the value of next. So remember, this is a linked list. This is a chain of linked lists, right? So here we're going to add another top-down level. Same stuff. Maybe we'll give it a different width, and we'll call it like Jesse. I'm just using random names here. And then same thing. We could then give it a next value, which is another linked list node. And we'll give it another level. We'll just pass in linear game. Maybe it gets a little bigger. And then we'll name this one Paul. And let's say this is where we're done. We could just add in a null. And then after everything's said and done, we add a semicolon at the end. And now we have a linked list of size 3, where the first node is Bob. It's a top-down level. Or it's a linked list node with the value being a top-down level. Name Bob. And that node next points to this node here, whose value is a top-down level, whose name is Jesse, and has a next value of this linked list node that has a top-down level, that's name is Paul, that's next value is null. So that's where it ends. So we have a node here, a node here, a node here, and a node here. So this is just one way of creating them. This is one value that you'd pass into your testing utility, and then you'd pass the other one is you'd pass in linear game dot get level list. So we added these levels here to our expected list. We would want to add these exact same levels to linear game. So we could do that a few different ways. We could loop through the expected list and populate linear game by using linear game dot add level, and then using each level and the value of this linked list. And then later, after we've added so I'd comment out here like add all levels to the linear game. And then after that, we would call linear game dot get level list, which I don't have implemented yet because that's a part of the task. But we would then linear game, I think it's get level list. Let me just confirm that really quick. Yep, it's get level list. So we would do that, and then we would pass into our testing utility the get level list and our expected list. And we would compare these two and make sure we get the exact same list of levels. So that's one workflow for the testing utility, or for the testing of this method here. And you could relay some of that information to advanced level. We might not need to use our testing utility for all of them, but I recommend to try to use it where you can. So definitely keep that in mind. And with that being said, that's pretty much most things I want to say about the LO. So I do just briefly want to say a few more things about the CU though. Okay, so for the CU portion of this task, you have to implement two methods. Okay, that's it. I mean, they're bigger methods, but it's only two methods, and they're find path and follow path. Now you're gonna have to make a class called pathfinding utils in the game.gameengine.utils package, right? And that's where the find path method will live. Follow path lives in agent. Now, again, doing this will help your task 4 a lot, but I'm gonna show some things to help make this process a little easier, or a little better to know if you're on the right track. So there is a pretty good description down at the bottom of the CU that gives you ways to let you test your code a bit better, since it's not going to work by default, since that's what task 3 is about. But this whole paragraph here is what's telling you about how to update your agent method or your agent class, because that's where all the pathfinding stuff is going to happen. So this paragraph below, though, gives you an agent class and a path tile class to download. Path tile is what's going to let you visualize the path like I showed earlier. So you're going to want to download this and put it in this location where it says, okay, download pathtile.java, place it in apps.games.roguelike objects. Okay, and then as for agent.java, this one is a little different, so I'm just going to kind of show you. I would open this one up and copy this update method and some of the instance variables, and then paste them into your agent class. So the agent class that I'm showing here is how it should look when it's all done. This is the actual code that was running. I added these comments and stuff, but this is the actual code that was running when you were seeing the example earlier. The thing is, though, is the follow path method. I'm not gonna show you that. That's the CU, but everything else is pretty much fair game for you to have, because that's what those paragraphs were describing to modify. So if you want kind of a tutorial of how I do it from scratch, I would copy this code from the agent class and then go to the example that I have here. This is what I was writing in earlier. I'd navigate to agent. Right below follow path, I would paste this update thing in. We're going to see a whole bunch of red errors. First things first, I'm going to cut out the instance variables and move them back to the top where they're supposed to be, up here. And then all these red, we just have to import these here. So Alt Enter will do that, or you can just press on the button. Make sure you're importing app.gameengine.utils for all these. That is very important, besides the array list. So path tile, this will only get fixed if path tile exists. So you could just, but the path tile one's easy. You just have to download it and place it here. But I'm just showing you this part because the agent class takes some like modifications. Like I said, we are pasting all that in, and then the update method, we want to fix all this stuff. So we want to import this level here, and all this will start clearing up besides, again, the path tile. But once I download the path tile and put it in, this would all go away. So with this, this will visualize their path if they have one. But we want them to actually follow the path, and that's what this paragraph like and bullet points here we're describing. And you could look at all of this and like write it all out. This is how I did it. I literally just read this and typed it out inside the update method. But don't get rid of this part of it. Right, this is still necessary. So write what it's like describing to you like above it, and it would be totally fine. That's what I did in the example that I just showed you before. Like this code right here is exactly what this paragraph is describing you to do. This one right here. So just do pretty much exactly this. You could write this exact code and it would be fine. I was just showing you how I do it from scratch. So, you know, I could just copy this over and boom, has everything I need. Of course, pathfinding utils needs to exist and find path needs to exist. So yeah, that's why I'm getting some red, but you'll write that all yourself. And yeah, I just want to show you some of that setup of how to get that visualization happening that I showed earlier. But yeah, one final thing I'll say about these methods is if you're stuck, I'm telling you, try to think about stuff with recursion for the find path one, especially. Follow path is a bit different. I think this one's personally the simpler one of the two. And if anything, this one's the real one that you should try to complete for task 4. It will make task 4 so much easier. But again, of course, I'll recommend both. Please try these CUs. It will be worth it in the long run for you. And that's all I have to say about these helper classes here that we give you. And yeah, so that's all I got to say about this task. It's definitely less to describe than previous tasks. It's linked list and inheritance. Things for task 3, we're going to step into some more of the agent behavior, and we're going to see how they will behave differently using trees and all that. But for now, I think this is pretty good. So hopefully you guys thought this was useful, and I will see you later.